or good night, depending on your time zone. Thank you for having me in this Notes 23 edition, where I can explain my use case around how Neo4j helped me to perform some dark web investigations and how this knowledge and how this graphic interface helped to me and my team to visualize some unknown patterns that involves this kind of investigations. Before I start the chat, a little bit about me. I have been working in cybersecurity since around maybe 22 years from now. Along my career, I have been playing different roles in cybersecurity, like first investigation, where I can help to other contribute discover some TTPs or techniques that attackers is being used. I have been working in forensic, pen testing, and more recently as a threat intelligence lead on financial sector, where this project born as a necessity from the company. And more recently, I have been working in cybersecurity operation manager. And a big overview, the agenda for today, it's explaining to you why this project burns, what are the basic requirements from the company, what is the thing that we need to discover from that. The second phase, how I start building the solution along my team, how it looks now, and some conclusions, and giving it some space from question and answers. Because I'm recording this session, the question and answers, if you got any, please let me know through my channels that I will share at the end of this chat. Thank you. Why this project burns? Basically, when you are working in cybersecurity intelligence, it looks like something like this. You need to create a hypothesis about how the threat actors are looking for the next target. Where is the motivation? Where is the capacity that the threat actor has, the infrastructure that they got, and how the potential tools that they will be used. You need to create an hypothesis around that. It sounds easy when you got information, but it's not easy when you don't have it. A lot of some of the pieces of this puzzle. Most recently, threat intelligence for me looks like something like this. Guess who? Maybe you know the game, but guess who is something like make some questions about the person or threat actor around it. What are the tools that this threat actor is using? How are the sum of indicator of compromise that is being related to this threat actor? Any potential attributes related to this threat actor, like crypto wallets, some user accounts, some email address, some IPs, some domains. Those are some basic attributes that normally you will find when investigating some threat actor, but it becomes harder when you are looking in the dark web, right? Because dark web, it's not an easy thing when you are trying to monitor a difference on the dark web against clear web. In the dark web, you can create a server, you can create a specific web service, but this web service will be available maybe a kind of hours, kind of days, or maybe some weeks, but it's not a long term. Normally, the dark web brings to threat actors some kind of anonymity because that, right? And as well, another difference against clear web, in dark web, you don't have any domain or any centralized domain register that could tell you who created this domain, who is the potential owner of this, what is the IP, the ASN, the internet service provider, or host server. Is nothing of this information are available in the dark web. That's why it becomes difficult to collect some information at the same time. This information is so volatile because I haven't explained you. The information normally lives by some hours, some days, and after that it disappears or changes to another domain or changes to another server that you normally doesn't find the IP address associated to that, or the domain, or the same route to find that server. That's why it becomes difficult, this, right? I will explain as well how I create the basic infrastructure to support, to collect, process, and normalize all the information before taking to Neo4j. In order to collect this information, I use some collectors, some server virtual machines in Unix based. These collectors has Python installed on it, has Turk agent installed, because if you need to go to dark web, you need to some kind of client, VPN client, to connect to dark web. In this case, I will use Tor. Tor is one of the most used dark web connectors, dark web VPN agents to connect to the network with the same name, right? Once I got this installed as a collector in the Unix based machine, I run a script basically to run onion search. Onion search is a tool created by Megados. It's a big tool because you are just writing a search term, and this term will be searching on maybe around 16 or 17 search engines in the dark web. It'll throw the results to a CSV file, and once you get this CSV file, you will be able to process all this information as you want, right? The other script that is along with this one, I have been writing a Python script that do all the process, right? All the process to collect, process, normalize, and save in a final file, because before being inserted in Neo4j, this Python script you will find in that address, in this GitHub address under my name, with the more details about it, right? But the basic concept about this is you need to run some collectors to acquire all the information, all the search terms. The search terms in the case of financial sector is something regarding to cards, BINs numbers, security numbers that is behind the card, the brand name or the bank name, if you want to see it that way, the competitors for that bank, and any other terms that is normally being used in the black market to refer to this kind of information that you will find. Some accounts, some card numbers, any other terms that it's being used along this investigation, right? This is a very big overview of how I implement this infrastructure. The whole process around it, just to explain a little bit better, it's when I run this script that you will find in my GitHub address. The first thing that it does is collect from a list of terms that I want to search. As I explained, these terms will be something related to our investigation. And in the case of banks, it's all the things relating to credit cards, bank accounts, or any other term that will be focus of investigation. Once the script gets this list, then it runs onion search around every of these terms. In my case, I have been run maybe around 100 or 150 terms. And once it runs as onion scan, as I told you, onion scan, at the end of the day, it will throw you on a CSV file with all the results. Part of the results contains the domain, the host domain, the URL, the full URL, and as well the searcher in which the result has been coming, right? And the date, and any other things that you can include in this search. But the basic thing is the domain, the onion domain, the URL, the searcher, and the specific date, right? Once that we get all these files is running through a normalization process. This normalization process, in my case, because the investigations needed, it's two different processes after that. One of these processes with the list of onion domains, I will run through a port scan, and as well any discover thing regarding to the network properties. open ports, the technologies that have been installed on that server. On my other side, running on kind of web scraping. This web scraping allows me to get more information about the URL that I try to investigate. What kind of information I can get? Email address, any crypto wallet associated with that page, any point of contact like phone number, maybe an account ID, or maybe a username that is commonly associated with a threat actor to make this kind of fraudulent transactions. And at the same time, I'm using other tools like enrichment, for example, to detect what is the main language in this URL, to create some tags around the content. I'm helped with the GA to get this information. For example, if the web page that I'm scrapping right now, it's doing some kind of transaction, fraudulent transactions, then the tag associated with that web will be market, for example, right? Because it's kind of fraudster transactions in the dark web, normally called markets. Then I will tag this web page as a market. If the web page that I'm trying to investigate is some kind of forum, then the EA will be associated with a blog or forum or other tag that could give me a big overview. What is the main topic of that web page, right? This is the thing that normally I do with this processing. And once I get this information, normalizing, some kind of sanitizer, and as well some cleaning, do some cleaning job on there. Then after that, I will inject this information to Neo4j. Once I get this, all the information collected will be looked at something like this, right? I wrote in this collector, as you can see in the right part of the screen. Once I run the search term, in this case, cards, against this search engine that is Amian, it will throw different results, different URLs. We will see on the center of our screen different URLs. That is the result of search engine. And this URL is normally hosted in a server with the domain 1, domain 2, domain 3. And as well, when I run the scrapping on the URL, normally I will find some email address or phone numbers. But as you can see, we are starting to having some kind of relations, some kind of node relations that it will be helpful to the investigation when performed. For example, hey, which URL is talking about markets? When I run this first search in Neo4j, the second part is, okay, what is the user or the user ID or the email address associated with these pages? How many users interact in that forum? What is the username that is normally common seen in that web forum? And if this username has been seen in another website, probably the URL too is not the same topic than the URL tree. But anyway, these two URLs, the thing that is got in common is the email address. Probably the same redactor, probably the same webmaster is giving the service from two web service or web URLs. And this is the thing that is starting to have informed, right? Having these kind of relations like, okay, what is the domain? What is the URLs hosted in that domain? What is the kind of services hosted in certain domains? And how, at the end of the day, these different servers, different URLs, different topics, it's being related, right? It could give us an idea as well. What is the capacities in terms of infrastructure that our threat actor has, right? This is in general terms how this information start related itself with the purpose of investigation, right? Giving some kind of a structure. That structure, this is how it looks when we are trying to, when I design the database for Neo4j, this is how the relations start looking, how all these fragments of data is being related, just with the purpose to start seeing how all these pieces will be related, how all these pieces will help to the threat intelligence analyst can be helpful at the end of the day to create some kind of intelligence around this data. We have here the main domain, as we can see it. For example, if we have been observed different mail address with the same domain, like proton mail, like anonymous mail, or any other email address, okay, how many email address, how many different email address belong to the same email domain, right? How many of these email address are related to certain URL, right? How these URLs bring to us with a different searcher, the search term that is giving these URLs as a result. Finally, the server that is being associated to that URL, the server that hosts this URL, the technology behind that server, what is this, the web server that is installed on that server, what is the server, when it has been created, and as well the different services around this server. Because normally when you're visiting the dark web, the most common thing to see, or the most common thing to observe, is the web server, right? It's an Apache, it's an Nginx, or any other web technology that provides some basic web pages. But behind the same Tor node, you will observe maybe other different services like an SMTP, FTP, SFTP, that could help us as well to get, or maybe to get any other additional data that will be helpful for the investigation at the end of the day. In this case, for example, in my experience, this kind of information allow us to unmask a threat actor behind certain infrastructure, because one of the servers got a vulnerability in one specific port that has been published, that is normally non-published, but because these informations will be able to uncover this operation thanks to a vulnerability that exposes any other information that is not commonly searched. That's one of the benefits of it. How it looks now at the end of this, basically, the thing that you are looking right now is how all this information looks when you are making a query on Neo4j. This basic query is, okay, the mail address associated to certain web pages. As you can see here, we have just two email addresses. The nodes in blue are the two different email addresses, and how this email address are normally associated with a Tor node, a server itself, and the different URLs, right? As you can see, these two different email addresses are being associated with the 46 different servers, right? What it means that probably these two different email addresses are talking about the same webmaster for all the servers, right? Maybe not different in content, but the same servers that are being distributed to ensure some kind of high availability for the web services provider. Or if they are different instead, the same webmaster for all of that, right? Probably we are talking about, maybe, I don't know, because it's a big overview, but this 46 servers could be 20 for fraud, banking fraud, or maybe other 20 for guns, or maybe other 6 for drugs, or whatever. But the thing is, at the end of the day, that you are having just two email addresses related to this infrastructure, right? Then it starts giving us some idea of what are the capabilities, what is the infrastructure behind these two threat actors. Other useful queries for us, it's, okay, how a certain search term is being related to other pages, right? Because in my experience with the financial sector, I normally look for cards, I normally look for identity theft, I normally look for BIN numbers, credit card numbers, bank institutions, bank names, right? How these terms, when I look or when I search or collect through the onion collector, how these terms at the end of the day related to other pages. Probably I get or I expect to be normally related to market, since uh, I have been seen as well related to some pages regarding to hacking, some other pages regarding to carding, other pages then related to. It's curious because it's related to some forums, basic forums that in fact it normally looks like the non-malicious forums and any general terms, but you can find some terms as well in there, right? Normally, when you are looking for a threat actors, the most common thing to do is looking on ransomware sites, leak sites, and you will be impressed by the amount of the information that you will get on common forums, right? Then this is other query that help us to find that. These unknowns, the thing that we are not knowing that happen in other sites, but thankfully to that terms, we will find in other websites, right? It's not just the search term. It's okay, how this search terms is being related, is being distributed along other websites. And this is thankfully to Neo4j, right? Because with the capabilities to create these kind of relations with all the information that you're collecting, how this search term is found or related to any different URLs, is how we can find this kind of knowns, right? This kind of, hey, I don't know that this search term is being founded in other forum, and thankfully for these capabilities, we will be able to find it. Other interesting search that we have been done with the Neo4j, it's okay, how these different terms is being related among, right? Because probably, as you may know, the threat actors are using most common words to refer to the final product. For example, in the case of banking cards, the most used terms as well is seed, right? Normally seed you will know like maybe a vegetable or maybe a plant or maybe a flower, it doesn't matter. But when you are doing these kind of relations and looking for a seed word, you will find as well some illegal activities or fraudster activities related to this word, right? Of course, you will find some results regarding to non-malicious or not fraudster thing, but when you are putting all together, when you are looking for search term related to that specific activity, you will be surprised by the amount of the threat actors or the fraudsters that are using this innocent word to refer to some fraudster activities, right? As this basic term, you will find another one or a lot of them that you will start knowing. Again, when you start looking for that kind of words, you will find another than being referring to these illegal activities. Then you as well can include in this list when performing a second round on a further investigation that is being throwing more results and redirecting to you to the same page, right? This is the interesting part on how it helps us to uncover these unknowns. Other interesting search that I have been running in Neo4j, it's okay, once I get these search terms, how it's being related, how the results of these search terms are being throwing some specific information. Other important or interesting part is, okay, what is the search term that is being thrown me and a big number of results? And this has helped me to do different things, right? One of them first is to look how efficient this search term is for my purpose, how the search term that I'm being used is throwing me some kind of false positives or true positives. It shows me efficiently on how to improve maybe the search, right? And by other hand, it's how these search terms are creating some kind of communities that is being related to the URLs, and these URLs as well, the server behind that URL, and to collect all the email address, phone numbers, account ID, username behind that search terms. If you can see my screen, if you see my screen now, you will see top 10 of communities constructed by the search term, right? As I mentioned, I have been used maybe around 100, 150 as different search terms. But with the capabilities of Neo4j, it's been able to create these kind of communities that help us to identify some specific communities behind that, and as well, creating a kind of barrier that reduce the surface of investigations, just focusing on some specific search terms. This is another benefit of Neo4j, right? Other than it's possible, maybe as a common database engines, to create some scalar vectors. In this case, I have been created this specific query just to know, as I mentioned, the other use, other sources that allows me to enrich the information is to collect the language, the main language that is being used in certain web pages. And this query shows me what is the most common used language in my investigation field. In this case, is of course is English. In the second place is German. In the third one is French. Then it gives me an idea of where the threat actors could live, where the threat actors could communicate. Again, based on the communities that I get in the previous page, based on the URLs, based on the search term. And if you can start building the puzzle of all of this information, we are giving some kind of idea where the threat actor lives, where the threat actors speak, where these communities are being related among us, right? It's a very good information. Other than, as I showed you before, how my search terms are working. It shows me the proficiency of the certain web searches terms. It shows me the search term with most results, right? That is to start talking about how this search term is being useful for investigation or being useless in the case that it's not throwing a lot of results, right? Just a big picture of how it normally looks. The idea is to try to show you in live, but unfortunately I cannot be able to do this demo on live. But if you want more information about, I will leave my point of contact at the end of the presentation. And other important thing, because normally when working in cyber threat intelligence or any intelligence agency, it's good to know how this information is being related. In fact, this information, when I start relating some kind of things for the analysts, for the common analysts, it'd be helpful, right? But when you are trying to present this information to maybe some people that is not being related to the technical part, not being related to how this information it's important, how this information is created, some kind of intelligence product for some data to the intelligence process. That's why I've been as well useful some integration with Splunk and maybe other SIM tool, right? That is helped me to getting these scalar values to present in a simple graph. It's barely visible here, but the thing that the data that I get about the language that is commonly being used, it's observing this pie chart. Other than the most common terms used, the most common results, it's thrown to this bar chart. In the cloud words, the most profit search term, the domain with most results, and as well how many servers I'm being collected, right? Because it's not just collect URLs, it's as well, as I have been mentioned before, what are the servers behind that web page, right? How many servers are being collected? Because this giving us an idea of how volatile this information, how many domains are being created since we are start running the search, right? how the potential threat actors are being moving and the technologies behind that. When I start with this kind of investigation, the version 2 of Tor are still available. Now it's not available anymore. Now all the websites that needs to be published in version 3. But when I run this investigation, the version 2 is still available, it's still working. That's why I'm creating this kind of graph that is telling me what is the specific version of Tor that the threat actor is being used. If this version probably is giving me an indicator of this server, this infrastructure behind that will be soon be expired, will be soon not being available, right? And in the last side, the most being used technologies with these servers, right? As I told you, what is the most common services or common technology behind the services? In this case, for this kind of investigation, the most used web service technology is Nginx. In the second place, Apache, and different other technologies that you will see. You can barely see here, but behind that, you will see some technologies regarding to SMTP, other technologies regarding to FTP, SFTP, right? And any other services as well that is not being enumerated or is not common to see. But when you are running this kind of process, you are able to collect this information too. And just to have a wrapping up of this, believe me, it saves my life when I try to run this investigation because the requirements for the bank is okay, guys. You need to find this specific search term that is being used for threat actors. You need to go to dark web and collect all this information. Normally, when you are doing that, it's like falling the rabbit hole. But with the help of Neo4j, we'll be able to uncover some operations of threat actors. In my experience, that is so good, right? Become as well easy to the analyst, experienced or not experienced analysts, to find some specific patterns to identify these unknowns, as we have been able to see during my chat, right? What is the specific patterns that we are looking for, and what the result of this pattern will help us to uncover these unknowns, right? Allow to us improve our quality of the data, right? I mean, in the way that we are collecting this, to observing how these results are profitable to us, what is the expected results, what is the result that we are getting, right? It helps to us as well to improve this data quality, right? On the fly, almost on the fly, because we need to analyze, but it's because the amount of information, it will reduce the times that normally takes to make this quality that we are getting, right? And most important part, that's the conclusion that we are getting, and the name of this talk is think out of the box, right? Normally, are solutions out of there that are still storing this information in a most basic structure on tables, and difficult to create these relations. That's why we are thinking out of the box and using this non-structured database engine, Neo4j, and that's why the name, right? There is not spoon, go out of the box, and thinking notes. Again, if you are wanting to know more information about this talk, please feel free to reach me through these different points of contact. I got my LinkedIn account, I got my X account, Twitter, and GitHub. In GitHub, you will find the full source code for all these operations, as well some documentation, some deep documentation about this. And just thank you again for having me, and hope hear you again. Thank you.